We are pushing the boundaries to keep improving our accuracy in terms of flood mapping. And I think in the end, the goal is to consider all these different factors and keep on improving models, creating models that give us timely and accurate flood warnings, and make sure that we keep on building resilience at the community level to reduce the impact of these floods.
Hi, I'm Stephanie Tumampos, and you're listening to Down to Earth, the show where we talk to incredible geoscientists about their science and its impacts on our planet. This season, we're exploring stories of resilience, hope, and scientific insight into climate change. Today, grab your umbrella and your watering can because we're talking about two types of disasters that are intricately connected: flood and drought. This episode of Down to Earth is brought to you by the Remote Sensing Environment Analysis and Climate Technologies, or REACT Technical Committee of the IEEE Geoscience and Remote Sensing Society. The REACT Technical Committee is a collaborative and supportive venue for all scientists and engineers looking to exchange ideas and share knowledge that advances our efforts to tackle climate change. To learn more and be part of this incredible cutting-edge committee, visit grss-ieee.org and select the REACT Technical Committee.
If you pick up any report, you'll find out that Asian Pacific, which is the majority of the global south, it's being impacted by disasters. It's usually in the top of the list. So I work with the remote sensing and GIS data and help the countries in Asian Pacific to build resilience to disasters.
This is Dr. Hamid Mehmood, Economic Affairs Officer in the Space Applications section of the United Nations Economic and Social Commission for Asia and the Pacific. He is responsible for developing and implementing innovative applications of space technologies to promote sustainable development in the Asia-Pacific region. As a part of this work, he also contributes to the development of the Regional Space Applications Program, which focuses on the use of space-based technologies to support sustainable development goals.
So studying floods involves looking at different things like rainfall patterns, river flow rates, topography, and historical flood data. And these days, remote sensing plays a big role in monitoring and predicting floods. It gives us information of, I would say, important information at a very high frequency, both temporal and spatial.
Hamid uses remote sensing to look at two different but similar types of water disasters, floods and drought. In these areas, Hamid helps to develop more reliable prediction models to help countries better manage water resources. Let's learn how. So I want to start by understanding how we use remote sensing to study and track these two aspects of the water cycle. So let's begin with floods. Hamid, can you tell us how we study floods? What remote sensing technology do we use and how do we use it?
So let's start with the satellite imagery. So if we keep it simple, satellites take pictures of the Earth's surface, including areas that are affected by flood. And then these pictures give us a general view of how big the flood is or what's the extent of the flood. In addition to satellites, we have other sources of data, which include SAR, that's the synthetic aperture radar, that uses radar signals to collect data even when there's cloud cover or there's bad weather. And with SAR, what we can do is that we can measure how rough the ground is and find water bodies on the surface, and which can help us map floods. So in addition to remote sensing, we have LiDAR. So LiDAR is light detection and ranging, and we can use lasers to measure the distance and create a detailed 3D map of the Earth's surface. And because we can measure elevation, we can map the riverbanks, floodplains, and buildings. And based on that, we can develop flood models, which can be then used to map flood or generate risk maps. And then finally, the other remote sensing data we can use is called thermal imagery. And when it comes to flood, we can detect the areas or spots which are warmer. And based on that change in temperature, we can detect the flood waters. So these are the main, I would say, 4 or 5 types of remote sensing data that can be used to map floods.
I've heard that it's very difficult to predict floods. Why is this the case?
There are a number of reasons which makes it challenging. I think the first one is the weather variability. Despite all the advancement in technology, it is very hard to accurately predict when and how intense a particular weather pattern is going to be. And I think this is something we experience daily when we use our weather apps. You pick up the weather app, you see there's going to be a sunny day, but when you go out, it's raining. And that happens globally. So weather patterns can be very unpredictable. And our forecasting models have a tough time catching phenomena like cloud bursting. Those are the phenomena which are very difficult to measure and monitor. The other thing that makes the prediction part very complex is the complex nature of the hydrological processes. Floods are affected by, I would say, a lot of different things like rainfall, soil moisture, river flow, and how the water moves around. And all of these processes are interconnected and further influenced by other external factors. And that makes the prediction of floods a very complex task. So we need a lot of data and accurate models to do it with a very high accuracy. The other thing that we face, especially in the global south, is the limited data availability. We've seen that the areas which have the highest risk flood historically have the least amount of data available. And the latest phenomena that we have started figuring out, and we think that that is contributing to the complexity of flood prediction, is the urbanization and land use change. As the city grows, the land use changes, and that can mess up how the water flows. And in the end, you get urban flooding, which is a very new phenomenon and very difficult to map when you're using remote sensing data.
Wow, that's super interesting. And I have so many more questions. But first, I'd like to take a quick look at drought monitoring compared with flood monitoring. Drought and flood are two sides of the same coin, right? So, how do we use remote sensing to monitor drought, and in what ways is it similar or different from monitoring floods?
Yeah, Stephanie. So what we observe is that both of the disasters at different timelines. You can start observing drought, but the impacts can be felt maybe 2, 3 years down the line. But the timelines of floods are pretty short. You would get rainfall, and probably within a week or so, you'll start getting floods downstream. But then again, the alarming part is that droughts are evolving. There's a new thing called flash droughts. So flash droughts would happen over a period of a month or so, and you will get this sharp increase in temperatures with the absence of moisture or rainfall, and that would cause a drought. And this flash drought would have similar kind of impact on your agriculture or on your economy. So this is a new phenomena, and if you look at the literature, we are still struggling on how to monitor it or map it because this happens so quickly that we don't have the data density in terms of spatial or temporal spread to actually start monitoring and have indicators which can go red whenever there's a flash drought. But if you look at what's been happening in the last 2 or 3 decades, yes, there's a categorization that droughts are slow setting. You have enough time to plan against them and do some mitigation against them. And floods, again, they don't give you a lot of lead time, but it's changing. If you look at the floods that are caused by cloudbursts, the lead time would be maybe 1 hour or so, and you need to plan in 1 hour. You need to take all kind of mitigation actions. And if you look at the frequency of cloudburst events that are happening globally, the numbers are going up every year. So you are on the right track that they are kind of connected to each other, but they are changing. I would say they're monsters that are continuously evolving.
I didn't realize that we have been having more frequent flash droughts and floods from cloudbursts. In both cases, that is alarming to hear because it sounds like there's not much warning. So, what are we doing to make it easier to make quick decisions about these types of disasters?
So yeah, that's a very interesting question. So it depends on which area you're talking about. So if you're talking about what are we doing in terms of science or technology or tool development, yes, we are increasing our data density. We are setting up more meteorological station. We are making sure that more data is available in open access domains to our researchers or scientists, so they can start using it and generate better understanding of these phenomena. But on the other hand, if you talk about mitigation, what's happening on the ground level, that's all about building resilience. That's about spending more money or investing in infrastructure, training people that whenever there's a sign of a flash flood coming in, what do they need to do? How do we make sure that we have adequate infrastructure available, that the water drainage is working and it's able to manage huge quantity of water in case of a cloudburst? We need to address or manage these issues on different fronts. At one point, we need to understand how they are changing, how they are evolving. And on the other hand, we need to start investing in infrastructure to make sure that we are ready to kind of make sure that there's enough resilience on ground to, I would say, decrease the impact of these disasters.
Well, this leads me to the question of how scientists can help policymakers with responding to floods and drought. What have you experienced in your work?
Yeah, I think my experience is that we need improvement throughout the cycle. Starting from the scientists, we fail to produce science which is easily digestible. Still too complicated. A decision maker or policymaker or politician still does not connect with the science or the results or the outputs that we're producing. In terms of policymaker, decision makers, or politicians who do listen to the science, for them, taking decisions or turning it into a legislation or actions, that is lacking. The pace at which we need to do these things is not there. I'll quote some of the statistics and you will realize that it's a sorry state.
I'm afraid to ask, but I think we need to address them. If my gut is correct, these are in relation to the Sustainable Development Goals. So I wanted to ask first about SDG 13, take urgent action to combat climate change and its impacts. Where do you think we're at with this target?
So currently, we are almost at a midpoint on our journey towards 2030, where we're supposed to achieve the SDGs. And frankly, SDGs are facing some serious challenges. A preliminary assessment of around 140 target was done recently. And the data revealed is that only 12% are actually on track. And close to half of the SDGs are moderately or severely off track. When we talk about SDG 13, we need to accelerate our efforts on about 60% of the targets. So that means that there are no targets which are achieved. 60% need acceleration. And out of the 100%, 20% targets are actually moving backward or stuck in one place. And this is not only SDG 13. You pick up any SDG and you will get these same kind of depressing figures. But this doesn't mean that we stop working on this. We need to keep moving forward, keep innovating, keep adopting technologies to make sure that we will make a dent. We really need to up our game at all ends, be it the academia or the policymakers, or even at the very end where people are adopting solutions. All of us need to really improve on how we start using all these advancements in technology and science to decrease the impact of climate change.
Coming up, we dive into some ideas for what scientists can do to help improve the adoption of technology and science for decision making. We also talk about the scientific advances that are enriching our flood and drought monitoring predictions. Finally, Hamid shares some inspiring research and models that are giving us hope against such dire SDG progress. All this right after the break.
Are you passionate about protecting our planet and tackling the challenges posed by climate change? Do you want to be a part of a remote sensing community that brings together the brightest minds in environmental science and engineering? Then you need to check out the Remote Sensing Environments Analysis and Climate Technologies Technical Committee, or REACT-TC for short. Here on the REACT Technical Committee, we believe strongly that interdisciplinary collaboration is key to making a real difference in our world. That's why we bring together experts from various fields to exchange ideas, share knowledge, and advance the science that drives our understanding of the planet. Whether you're a scientist, engineer, or simply someone who cares deeply about the environment, the REACT Technical Committee of the IEEE Geoscience and Remote Sensing Society is a place for you. Together, we can make a difference, one discovery at a time. Visit grss-ieee.org and select the REACT Technical Committee to learn more.
Welcome back. Today we're speaking to Dr. Hamid Mehmood, Economic Affairs Officer in the Space Applications section of the United Nations Economic and Social Commission for Asia and the Pacific. We left the conversation with some depressing statistics about the slow progress on the Sustainable Development Goals. But fear not, dear listeners, because our conversation didn't end there. Instead, we began exploring how scientists are persevering, continuing to move the research and technology forward, and working to ensure it is adopted. Let's dive back in. So, what can scientists be doing to help improve the situation? You mentioned that we need improvement throughout the cycle, from how we train scientists in academia to how we encourage policy and technology implementation on the ground. So, in your view, how would we start working on this?
Okay, number one, try to pick up problems which are relevant. right? So if you look at the amount of science or the research that's being produced, it's humongous, right? But how much of that research actually solves on-ground problems? That is going to be very small in terms of percentage. That is why I would say the academic system is broken, that a professor or a teacher is graded on the number of research papers rather than the impact of that research. So that is something that we need to fix as step one. Step two is that all of the research that's being funded should have an on-ground impact. If we are funding a research and then we know at the end of the day that the output would not have an impact or positive impact in terms of improving the quality of life or mitigating the impacts of climate change, then there's no point in doing that research, considering how critical things are right now. So there has to be a realization that systems need to be improved, be it global north or global south. All of these things need to be improved.
Yeah, that makes sense. And you mentioned something like the huge amount of research being produced. That made me think of big geospatial data. I mean, the amount of data we have access to globally is enormous. So, is big geospatial data improving our ability to develop impactful products for flood and drought monitoring?
Yeah, I think big data sets have been critical in recent years to how we do analysis in remote sensing work. This big geospatial data set has changed how we not only do flood mapping, but also do drought monitoring or crop monitoring. And this is just the start, I would say. If you look at the major repositories of big geospatial data sets, they are growing and they're growing in petabytes per year, and which is a good thing. But the other thing that we're seeing is that we need to connect the remote sensing data to ground data. If we don't do that, then we don't have accurate models. Relying on geospatial data to do nowcasting or forecasting or hindcasting will not give you the required accuracy. And this is where the local or national level data cubes come in. Those are very rich in terms of the geospatial data set as well as the statistical data set. For flood mapping, this is super helpful because you can look at the historical data set, you can create stacks of imagery, and then you can do this temporal analysis. As I would say, the cloud computing capacity increases and it becomes cheaper, the accuracy of the models, it keeps on decreasing. The time that they take to compute, it keeps on decreasing. So yes, things are moving forward and it's looking good. And hopefully when we integrate it with the machine learning or the AI models, we will get accuracies or outputs which will help us generate bulletins or warnings without any human intervention. And those warnings could be used in near real time.
You mentioned local data cubes. Have you helped to coordinate the creation of these data cubes?
Not directly, but we do interact with the national space agencies. For example, in Thailand, we're working with JISTA, and Indonesia, we're working with BRAIN. So both of these countries are setting up their own national data cubes. In Thailand, they call it Sphere, JISTA Sphere. It's available online, and it's everything and anything to do with GIS data in Thailand. So you see these initiatives in Global South, which are focusing on local data cubes, because what these data cubes do is that they ensure that the countries, they maintain the ownership of the data, which is very critical. You do hear about data being the new oil because that is going to drive the economies, that is going to generate a lot of revenue. And it's very critical for those countries to keep this ownership of the data set. That is very important for them because they will be generating insights and information products based on these data sets. So yes, we do work with space agencies, and we try to ensure that while these data cubes are being set up, they are shared with the local ministries, and the data from these data cubes are ingested in the systems that are being developed at these ministries.
Well, that's positive to hear. So basically, one way we can support better climate change mitigation is to support countries in developing these data cubes. Then we'll have the geospatial and statistical data sets to develop time series of country-specific flood and drought events. What else can we do to support countries? How about specifically in terms of tackling the SDGs?
So at ESCAP, what we're doing is that we're going an extra mile, and we're working closely with the ministries to ensure that the tools and technology that we provide are actually put in use to make decisions. So we call it uptake. So we try to ensure that there's an actual uptake. For instance, what we did is that we set up a drought monitoring system in Central Asia, particularly in Kyrgyzstan. We call it KERES. And that system was set up at the Kyrgyz Ministry of Emergency Situations. What we're doing is that we're working with them to make sure that the system gets used at national and subnational levels to make decisions and do some kind of policy making. Similar is the case of ensuring adoption of the CropWatch monitoring system. So we're working with the Chinese Academy of Science. They got an excellent system called CropWatch. And we're working in Cambodia and Laos. So there are two things that we're doing. Number one, we're training people in Cambodia and Laos, the expert at the ministry, to train them on how to use the system. But on the other end, what we're doing is that we're helping them calibrate the system so to make sure that the system is actually used as part of their decision-making process. And all of this is very tough because it takes not 1, 2, it takes 5 or 6 years to make sure that you close the loop. And it is a tough challenge, but we believe, and I think if you look at the literature, research backs it up, that this is the way to make a real impact, that you don't leave it halfway through. You need to close the circle and you focus on the adoption and implementation rather than just the technology transfer. So yeah, this is what we're doing for SDG 13, and this is our modus operandi. We do understand there's a realization all around that we don't have enough time. Starting today, we have around 6.5 years to make sure that we deliver on SDGs. And like I said earlier, we really need to up our game.
Speaking of tool adoption, you completed a study to test the accuracy of a new flood mapping algorithm that used cloud computing and Google Earth Engine. When we were speaking earlier, you mentioned that while Google Earth is an excellent tool, globally there are very few agencies or ministries using it in their decision-making or policy work. So tell us a bit about this tool and how you're overcoming this adoption issue.
Okay, so let me give you a little bit background on this. I started working on this paper and the tool when I was at UNU Inway. Now at ESCAP, we are still building on the idea presented in the paper. And in my section at ESCAP, like I said in my intro, that our focus is technology transfer. And unfortunately, what we've noticed in the Global South is that there are significant obstacles when it comes to learning and adopting these new tools. So what we aimed to achieve with the tool was to pack a robust surface water mapping model in a way that anyone could use it. And at the end of the day, it should give an acceptable level of accuracy. So what the tool does is that it allows a user to map or analyze the temporal surface water pattern in their area of interest. And the best thing about this tool is that it's a point-and-click tool, meaning that you don't have to code or you don't have to do any kind of data engineering to actually start using it. So we launched the tool in 2021, and at that time it gained a lot of traction. It received the Popular Science Best of What's New Award, and it was also featured in the 2021 UN Innovation Compendium. But a lot has changed since then. There's a technology out there, and over the past 2 years, we have started collaborating with experts to further enhance the tool. And we are planning to launch the updated version at some point at the end of this year. And that tool will have better, I would say, accuracy in terms of mapping the surface water, especially in Global South. So if you look at the main objective behind the tool or the paper, you will find out that the main goal was to empower individuals and organizations with a user-friendly tool that can help them, I would say, understand and manage surface water patterns. And we feel that we have achieved some part of the goal, but there's still a lot to be done. We still need to improve the accuracy because in some regions, the accuracy does suffer and it's not at acceptable levels. But but when you start looking at those ministries and you start looking at the researchers in those countries, there's a lot of support and there's a lot of good feedback coming in. And hopefully when we make the announcement for the tool that's coming at the end of the year, there will be positive news and there will be very good accuracy levels.
So this tool is still a hindsight tool, or can it be actually used for forecasting and mitigating flood?
So this is a hindsight tool. We are not focusing on forecasting because there are a lot of tools and models already out there which are doing forecasting. What's missing is the hindcast. Actually, if you look at how the remote sensing data is being used in the cycle of hindcast, nowcast, and forecast, you will see that the majority of data is used either for nowcasting and forecasting. And very limited amount of data is being used for hindcasting. But if you talk to the decision makers and policy makers in Global South, they will say that any information related to a historical flood is really, really, really important for them, because that helps them to build back better. That tells them that which area was impacted last time and which area to focus on. So essentially what it does is that it maps out the hotspots for them.
Well, I definitely look forward to seeing the revised tool when it's launched at the end of this year. Thank you for sharing that example, Hamid. As a PhD student with concerns about climate change and the relevancy of my own work, it's nice to hear about work that directly benefits decision makers, especially in light of the dire progress on SDGs that you mentioned earlier. And speaking of the SDGs, what would you say to other young researchers to give them hope about their work going forward?
I think there are success stories, far and few, but there are. But the thing is that if you're not making progress, that should not stop us from keep on having a go at it. Resilience is part of human nature. That's how we have survived so many years, right? There have been numerous challenges throughout our history. There were world wars, and we came out of those world wars. And then we survived, and there's resilience. And if you look at every time we came out of a challenge as a human race, it was all because we put in a concentrated effort. And that is what we need to do now in terms of science, is that we need to get our focus back. We need to make sure that we are doing research which is focused on a problem that is very relevant. And that would be my message to young scientists, that if you start doing, for example, your MS thesis or your PhD thesis, try to pick up a research topic that connects to something or a problem that's happening on ground, and try to make a contribution to solve that problem. A contribution could be understanding the nature of the problem, or there's various dynamics. And this does not have to be always related to analyzing data or developing technology. Let me give you an example of the adoption of AI. We do say that we need to adopt AI, and AI is going to be one of the catalysts that's going to help us achieve the SDGs. But a very critical angle or very critical thing that we need to sort out, where we need social scientists, is responsible AI. That we need to make sure that whatever kind of AI is being developed is not a black box. It's being understood all over. It's being understood by all the stakeholders. So to cut it short, my message to the young scientists would be to please be very aware of the research problems that you pick up, and make sure that there's a connection to real life problems.
On that positive note, we'll wrap up this episode of Down to Earth. Want to learn more about Dr. Hamid Mehmood and his work at ESCAP?
At ESCAP, you can go to escap.org. And if you want to reach out to me personally, I'm on LinkedIn, so you can search my name, Hamid Mehmood.
Don't forget to follow and rate us on Spotify and Apple Podcasts. And send some love to our sponsors at IEEE_GRSS on Twitter and Instagram, and IEEE Geoscience and Remote Sensing on Facebook and LinkedIn. This episode was produced by Nicole Bedford from Nicole Bedford Films, with help from me, Stephanie Tumampos. Graphics and design by Mylene Briggs of Kila Media. And a special thanks to Irina Hansek of ETH Zurich and the German Aerospace Center for her support. I'm Stephanie Tumampos, and you've been listening to Down to Earth.